Hi, Chris Carlson here with Jose Martin-Garcia. I'm a user interface developer, and Jose is in the algorithms R&D group. And we're going to tell you about what's happening with Dataset. I'm the developer of things concerning the front-end interface aspects of Dataset, and Jose works under the hood, so to speak, on the computational aspects of Dataset. So what we're going to be describing is these projects are underway right now and will be rolled out sometime after 12.2. So because they're in progress, you and your comments can have an effect on the course of the development. So we would like to hear from you, your comments and questions. So please direct those to the chat, and then at the end of the talk, we'll address those. So for those who may not be real familiar with Dataset, let me just give a brief introduction. Dataset is the main concept in Wolfram language for dealing with structured data sets, by which I mean nested lists and associations. So here is a data set, which is a list of associations, and you get the list elements going down as rows, and each column corresponds to one of the elements of the association. So some functions in Wolfram language will return data sets as their return values. There is some interactive behavior on data sets. They scroll, you can drill down and back up and so forth. But for the most part, they're output only. So the first project that I want to talk about is dataset editing, and I have a prototype that I can show you briefly. So here's a data set, and in the prototype I'll click here, edit 333 and return, and I've done a quick spot edit of that value. Now in this prototype, it pops out a dialog window, but in the final product, it'll be editing in place. And the way that you initiate an edit will probably be by way of like a menu bar that pops up when you hover over the data set or something similar. So you will have complete access to navigation. Whoops, what's going on here? This is not evaluating. Something odd going on. Hang on just a second. It is. Well, I don't know what's going on here. For some reason, it's not giving me any outputs. Let me open this talk anew. Oh, here we go. Okay, I don't know what was going on there. All right, so there's full navigation while you're editing. So if I say here edit, I'm tabbing through here. And then you can scroll and edit, drill down and edit. And so forth. So all of those edits are reflected then in the data set. Dataset displays some things in special forms. For example, quantities are not displayed as quantity, but they have this special form within Dataset. When you edit, everything is displayed in input form. Otherwise, some of these things would be impossible to edit. So you have access to both the quantities and the amounts and the units when you're editing. And similarly for other things like geolocation or those kinds of things. If you have an item display function, so item display function is a function you can interpose between the content of the data set and the way it's displayed. So if you have an item display function and edit, it shows you the underlying content, and then when you're done editing, it pops back in and applies item display function. If you edit an item completely away, then the resulting value is missing. And if I go back and edit this one now, you can see that it's inserted that missing value, which you can replace with another edit. As I said, there's navigation while you're editing. Sometimes it elides items. If I drill down here to B, well, you can see there's a BC which has been elided. When you're editing, you can navigate down to the elided items to edit those as well. So with the possibility of editing data sets, by using placeholder, you can essentially use data sets as input forms. So probably in the finished project, if there's a placeholder, you click on the placeholder, it'll automatically bring up the editor. But you can, now I can tab through here and enter values as if I'm doing entry in a form. Okay, so that's dataset editing. Now let's talk about dataset themes. So themes may be familiar to some of you from plot themes, and dataset themes are analogous to plot themes. So here is a default plot, and if I add plot theme marketing, then that pulls in a coordinated set of options that give the marketing style. And these can also have sub-themes like large labels that you can fine-tune the plot themes. So we're going to apply the same idea to dataset. And this is not yet prototyped, but this is the proposal. So these are the basic themes, which are analogous to the plot themes for dataset, giving you minimal, classic, monochrome, and so forth, dataset themes. And then we're also discussing a number of additional themes. For example, like these, line printer paper. I remember what a line printer is. I don't know if everybody listening does, but that has indexed rows and columns. It makes it easier to follow in long rows and columns. A heat map, for example, which color codes the value in the cell. Here's a tooltip heat map, which is a heat map where the values are hidden but are revealed by tooltips. Histogram, for example, where values are indicated by bar charts. So I'm especially interested if any of you have requests or ideas for plot themes, mention that in the chat and we'll talk about that after the talk. And like all dataset options that affect style, you can apply a plot or a dataset theme to a sub part of the dataset. So for example, here I've said I want to apply the histogram theme to the age column, and that gives me bars here, and I want to apply a hypothetical check mark theme to the survive column to translate that in check marks. Okay, that's what there is to say about editing and themes. I'll hand it over to Jose, who will talk about improvements to the type system.
Sorry, I was muted. So I'm going to be talking about ongoing work on the type system of dataset. So dataset needs a type system because it's fundamental in the choice of layout of the result, and also to perform faster queries. So the type system is stored as second argument of a dataset, and it has its own language in a context called type system. I have added the context to the context path so that we don't see continuously dataset backtake or typeset backtake objects. And yes, and something else I wanted to point out is that as we discussed in the conference last year, we have removed the ID components in the third argument that were problematic when comparing two data sets that were identical in content and therefore type, but not in IDs. So now this works in a different way. And so what we do is that the third argument is now used to store the options and option values of dataset, like here, the background color. Okay, so some properties of the type system of dataset. It's a tabular type system oriented towards the types of elements in arrays, possibly rugged arrays. It's not a general type system. For example, when working with the data set, we don't need to worry about function types. So it's not as general as the compiler type system, for example, but it goes into a lot of detail for the tabular data. It focuses in controlling fundamentally lists and associations, and everything else are considered atoms. And there are special cases that right now are still considered atomic, like sparse arrays, time series, or even datasets themselves, but that may change in the future to convert this into also specially treated array containers or data containers. So I want to very briefly show a few examples of types. The main function is a function in the type system context called deduce type in this context. And for something like 3, it will return atom of integer, where this atom is again something in the type system contents. For a string, it will return string. For quantities and entities, it stores part of the information, the units in this case, or the domain in the case of units. And for other expressions, it returns any type. Now for lists, it will do something like this. For a list like this, it will say that we have 4 integers. And vector means homogeneous list. This is a homogeneous list in which all elements are integers. If we have nested lists, it will effectively work like dimensions. So we have a homogeneous list of a homogeneous list of 2 elements, each of them being a homogeneous list of length 3 of integers. If the array is rugged, then we have something like this. We have 2 lists containing lists of integers of different lengths. And then we have this symbol here, any length. And if the list is not homogeneous, then we have this different object called tuple, which will list the types of the individual objects. Okay, that's what we do for lists. So the main thing is to distinguish homogeneous lists from inhomogeneous lists. And for associations, something similar happens. We have a homogeneous association of integer values, 3 of them. And when the list of keys is short enough, then we enumerate them. If it becomes too long, or long, I think there is a threshold at around 16 or something like that, then this will just say string. And If the association is inhomogeneous, then we have another object listing the keys and the types of the values. Okay? So these are the elements of the dataset type system, and they can be combined as obvious, in the obvious way. Okay, so because every computation with dataset, starts by, every construction of a dataset starts by computing the type, it's critical that this computation of type is fast enough. And so this has been one of the main things this year, improving the speed of dataset. So to play with examples, let's use our planets example dataset. So this is the data it contains internally. So it's a bunch of nested associations containing quantities and other associations. And it is 160 kilobytes. So it's not very large. So if we compute the type, we get that. Actually, it's a bit slower because sharing with Zoom, this becomes a bit slower. But yeah, it can do it in a fraction of a second. But it's a small data set. So let's now go to a larger data set, 160 megabytes now, which is 1,000 times our data. And so we have find here two issues, apart from two issues. The first one is the following. This takes now over a second, which, I mean, for 160 megabytes might not be so bad, but the problem we see here is that even though this recognized that it is a homogeneous list of 1,000 objects, it actually didn't give us the type we had found before for the individual object. So yeah, so the first element there is not the type that we found before. And so this is something that is not convenient. The second thing is that this actually didn't look at the 1,000 elements there. There is a variable in type system called deduction window size 32, meaning that the type system is actually looking at the first 32 and the last 32 rows. So we are going to change that to infinity so that now we force the deduce type to actually look at the full object. And so this now becomes slower. And this now becomes a bit too slow. So we have a new type system, and what we are, it's right now it's in the, it's called new deduce type. And now we compute the type of the original data. This is just to check that we get exactly what we were getting before. And you see how instead of 0.01 seconds, this is now faster. And with the large data, and this type system is looking at the full list of 1,000 elements, we get something under a second. And you see the first element is also the type that we had at the beginning. So now this stability condition is obeyed. I will comment in a moment why we need this here. For example, just to give you another example, this is a list containing 1 million numbers, some expressions, and another million numbers again. So with the previous time system, this will take the order, I think, of 6 seconds. And because it realizes there are mixed types, it returns any type, and this is the length of the object. With the new type system, this is much faster now. Or for example, take the 249 countries of the world as entities. Now we choose like 1 million of them, random choice. And again, how long does it take to compute the type of this object? It's also a number of seconds. And if we do it with the new type system, this is a lot faster. Now you may think, just to compare and to give you a sense of the speed of this, you might think this was just a matter of extracting all domains from all the entities and then deleting duplicates. So if we time this operation, we see that it is slower than this one. So this gives you a sense of the efficiency of the code here. Now, how do we use it with dataset itself? What I've done is to introduce the switch. So by default is false, which means that it is using the previous time system. So as Chris said, this is ongoing work, and for 12.2, we are not planning to activate this new type system. We want to test it a lot more. But if you want to test it, switch this variable, and yeah, if you have comments, or let us know. So these are, you see, the timings of construction of the data set related to the construction of the types. So now we activate it, and we see how this becomes now faster for the two example sets that we constructed before. Now, the new type system has a couple of arguments controlling how much you want to report about the system. For example, here, this 8 means this is the threshold between homogeneity and inhomogeneity. For example, in this case, we decide that 8 is still good enough to report all the keys in an association. But if you say 7, then because there were 8 planets reported there, it just gives you a homogeneous association saying, well, they are all strings. We don't care about the names. Something similar happens with enumeration. So this additional argument, it's going to control whether you allow enumeration or not. By default, it's deactivated, so effectively this is 0. But now here you say, I want up to 4 keys being enumerated. And then you will get, rather than string, you will get enumeration objects. So this is just a way to control the thresholds so that you get more or less information. And this has an effect on the layout of the dataset. For example, this deduction of types can be applied to arbitrary expressions that are arrays. So let's take, for example, the biggest polygon object that we handle, which is the more than a quarter of a million points. So we can use this to report what we have. And so it will report correctly that we have 1851 lists, each of one being lists of pairs of reals. That's what this means. Now, if we do it with the new type system, we get the same result, but faster. Another example, groupings. So for example, we have this function, groupings, to construct combinatorial objects. And if we ask the type system what this is, it's effectively dimensions. It's just saying we have 54 pairs. But if we sort them, now we get more information because we have more consistent structure. We have 54 pairs, but now we have the information that the first element is an integer and the second is a pair of integers, right? They all have been sorted in elements of this form. So you see how this also becomes some sort of rugged dimensions. So this generalizes dimensions to report more structure. So this can be useful in analyzing, I don't know, the internals of graphics or whatever. And then I have a bigger object here again. Let's evaluate it. This will take a few seconds to download. So this is downloaded from the New York Times. The data updated to today of COVID data for all the counties in the US. So this is a data set of, again, nearly 160 megabytes. And so let's take just some random choice, and we see that what we see here are lines of the form string, so date, string, string. This is some code for the county, number of cases, number of deaths. And so again, constructed that data set with the current type system would take, I mean, assuming we look at all the rows, which is what we have to do to avoid missing some incomplete information or incorrect information, right? So that's what it took. And you see it's a data set with this number of lines of rows. And so with the new one, it takes less than a second. So that's what I had prepared. So now, yes, we will take questions. And as I said, this will not be by default on the 12.2, but if you try it, please let us know, and or whether you find some case that you think it should be still faster. Okay, let's see, we have questions, both either for me or for Chris.
Yeah, I've been paying attention to the chat window. There are lots of good suggestions. Thank you for your comments. A lot of people asked about pivot tables functionality. That's come up in our discussions about Dataset. It hasn't bubbled up to the top of the priority list, but if it's apparent that there's large demand for that, it could. There have been other suggestions for labels on bars, spark lines, that's a great one. Search functionality and Dataset, I've made note of all of those things, and we'll consider that. Some of you have mentioned export issues. For example, you export something as CSV and it gives you date objects. I'll look into that. Export is not, export happens kind of magically and is done by another group, but I'll check that out and follow up on that. Let me just go back and have another look at the chat window. There were a couple of questions I think you could address, Jose, about the type system.
Yes, so I see a question here about support for lots of quantities inside. Yes, so the idea is to have different internal representations. Given that dataset is atomic, we can use the opportunity to have internal representations of things. And so we now have a quantity array and other types of structure array to represent quantities and other things more efficiently. So we will be making use of that. And there was another question. Yes, missingness. Yes, so the type system, the new type system does accept a fraction of the elements being missing, and then it will explore the equivalent cases in other rows to deduce the type. If there is consistency between the types of all other elements except for the missing ones, then it will assume those missings had also those types.
David Broda has asked about zoom in and zoom out. I presume what you mean is to change the size of the scrolling window, the number of things you see when you scroll. If so, yes, that's one of the things that's on the agenda, is to provide a resize thumb in the corner of dataset output, so you can do that. I think our time is about up. It's 12:30. There's one quick question. What about import, export to pandas and data frames? That is certainly something that we should consider, and I'll make a note of that.
Right. Actually, if you use the external evaluate about Python and you import pandas object, then it automatically comes as a dataset object.
Yeah.
Yeah, so just one comment on time series. Yes, we are working on how to merge in a better way time series and dataset.
Okay, well, I appreciate your comments. Those are all very helpful, really great issues. If anything else comes up or you want to lobby me or Jose for some functionality, send email to carlson@wolfram.com and we'll give it a look. Thank you.
Thank you.